All right. Welcome back, everybody. Today, we will be doing practice with lists, and we'll be doing some diagramming, as well as a little bit of interactive programming. So I would encourage you to be ready for both of those things. A couple of quick announcements before we get into it. So great work on the quiz and getting this project in. I know it was a push to get all of that done. What I'll remind you of is that we are doing office hours today and tutoring this evening. So if you want to go over your quiz, I would encourage you to come in and work with us in office hours or tutoring for conceptual help. And beyond that, there are two new things to be aware of on the calendar. So I'm going to pull up the course page real quick. So the first is our first reading of the semester is out. This is a chapter from the book Ethical Algorithms. And you can find the reading in the Course Reserves tab on Sakai for the course page. There are also some related questions on Gradescope, and there's a 2-week turnaround on this. It's relative to the readings that you've got in other courses around campus. This one should be pretty short, but we want to give you ample time to do it. And so you've got 2 weeks on that. And additionally, the next exercise is list utility functions. And so on Tuesday, you all watched the introductory conceptual videos on working with lists in Python. Today, we'll be getting practice with that. And after today, you'll have everything you need to know in order to get started on the list utility functions exercise. Right? And that's the usual deadline of next Wednesday. So we're trying to keep a pretty consistent schedule here. After lectures, we've got lesson questions. They're due the next day by midnight. With exercises, they're typically due a week after release. And then with readings, this one's 2 weeks. The rest of them will be 2.5 weeks, and there will be a few more. All right, so those are the announcements. We have some practice that we'll be doing today with our lists and diagrams. So we're going to jump straight into a practice question here. And before I turn it over to you all, I just want to point out some things as a quick review. So on Tuesday, we learned about the list data type. So we're saying A is a variable that can store lists of strings, right? And on the right-hand side of this, what we're seeing is list literal syntax, right? So here we're setting up a list with one item in it, and that one item is the string with the word one, or the characters O-N-E. Right? On line 5, this is actually going to be where we spend most of our time thinking on this diagram once we get into it. But I want to give you a chance to try imagining how this works first. But we're saying B is assigned A, and then we are appending to the list A. And append is a method every list has built into it. Right? And it says you can add one item to the end of a list, and we're adding the string 2. And then we reach sort of this interesting question of what happens when we print B of index 1. And as you think through this, you'll probably think there's one of two possible things that could happen. So what I want to give you a brief fair warning on is that lists behave a little bit differently than some of the other variable types we've seen so far. Before I show you how they work, though, in order to help make the contrast more clear, I want you to try diagramming this in the most natural way you think is possible, and do this as quickly as you can. We'll do this in like under 5 minutes, and work with your neighbors. 1, 2, 3, go. One more minute on this, one more minute. All right, I'm hearing folks in the audience, the conversation's dying down. So as I said, there's something that's surprising that's going to happen here. And it's going to shatter how you think about variables for a brief moment, but we're going to talk through it. And as long as you have thought through how you think this should work, it will help increase the contrast between how it actually works in practice. So the first thing that we need to figure out is, how do we represent a list literal on the heap? In Tuesday's videos, you saw kind of a preview of this, but we didn't address it head on. Lists are stored in the heap, right? So you could imagine a world where maybe A was like something like this, right? 0 and 1. But it turns out this isn't correct, right? And we'll talk about why in just a moment. But for now, what you need to know about lists is they're going to have representations on the heap. So just like functions, we're going to see lists there. And the way that we're going to represent them is we're going to take the type of the list, so a list of strings, and use this as sort of the header to a table, right? And what that table is going to contain are the items and the indices of those items to make it easy to look things up. So our index is going to be in the left-hand side column, and we're going to have 2 columns here for our list. And the value associated at index 0 is going to be the string 1, all right? And I'm just going to label this for reference purposes. So index is on the left side column, and value is on the right side column, okay? Now, from here, we have this sort of disconnect, right? Well, we have this named A that is in the globals frame, and this object that's this list type on the heap. How are they connected? Well, they're connected through, and I'm going to use another color here to emphasize it, what we call a reference. So A references this list. Just like we've had arrows that connect the name of a function to where we can find that function's definition on the lines, here we're saying A refers to this list. And that's going to be important. That distinction between, we're not saying A is this list, A refers to this list on the heap, all right? Now, what happens on the next line? Right, so here's where what we've learned so far gets a little bit interesting. What we've seen with other types of variables, like integers and floating points and booleans, is when you take one value and assign it to another, you're copying that value somewhere, right? So if we had like, x is 1 and y is x, we would have had in memory, x is 1 and then y is 1 after this, right? With lists, this is going to be more nuanced, right? We're not going to make a complete copy of the list, because if you can imagine having to draw a complete copy of the list is pretty tedious. And it turns out if we had tens of thousands of items in this list or hundreds of thousands of items, it would be even more tedious. And it would be tedious to the computer as well. So what we're actually copying here is what is A. So A is not this list, it's the reference to this list. So B is also going to be a reference to this list, right? And this is a key distinction in the differences between how we think about the assignment operator when we're working with lists, and what we'll come to see are called other reference types. And we call these reference types because the variables store references to the actual values here. So B is a reference to this list, and A is a reference to this list. And now both A and B refer to the exact same list in memory on the heap. So they're aliases of one another. It's like, my legal name is Christopher, but I go by Chris. Both of those names refer to the same person. Here, A and B are both names that refer to this list that has a single item in it, right? And this is where you need to be careful. What I would encourage you to emphasize as the intuition here is looking at, okay, what is A actually? What is in A's box? What's in A's box is this arrow that points to this list. And so when you say take whatever A is and assign that to B, we're saying take that arrow and make B an arrow to this box as well. Now I want to point out one more caveat here. Where this arrow is pointing doesn't matter, right? So what we're pointing to is not something inside of the box. What we're pointing to is the box as a whole. So don't don't read too much into where these arrows are pointing, other than the object that they're referring to on the heap, right? Nothing changed about these arrows or the representation of what they're pointing to in this example as I'm moving these arrows around. What we're saying is both of these, A and B, refer to this list object, not something inside of it. And this will be true throughout the rest of the semester as well when we see other kinds of objects on the heap. All right. Let me move on to line 6. So we're saying a.append and then the string 2. Right? Whenever you see this dot operator, so a dot, what that means is we're following a reference, right? So A is this box here on the heap, or sorry, on the stack, and then the dot is saying follow this arrow, and then what we're saying is, okay, with this list object over here on the heap, that's where we're going to append some new string. And I lost my pen here, there we go. So I'm going to append to this list. That adds another item to the next index, the string 2. All right? So that's line 6. On line 8, we're trying to look up, well, what is stored in B of index 1 using the subscription notation? So we look in our globals frame, which is our current frame. We ask for, okay, what is B? And then when we use subscription notation, we're once again looking into this table and saying, okay, what's at index 1? And the output of this example would be the string 2, right? And so notice that by appending to A, because A and B both reference the exact same list on the heap, we're effectively appending to B as well, because both of them refer to the exact same object. Questions on this example? All right, so this same technique and the same underlying principle is going to apply when we call functions as well. Oh, we got a question here in the back, if we can get... I'm going to keep talking through what I was about to say, and then we'll get to this question. This same underlying principle is going to apply to functions as well. So when we call a function with an argument that's a list, you're not going to make a copy of it. You're going to be passing a reference into that parameter, and we'll see that in the next examples. But let me take this question.
So if you append B, does that also append A?
Yes. So great question. So if I were to have had another line here, such as b.append, and then I'll just put a question mark for our question, and not append, and that would have had the effect of having, b dot follows, the dot follows the arrow. We're talking about this list object, and now we would have a question mark appended to this list if we had added that line.
So if we printed like A of 2, it would print question mark.
Yes. Yep. So these, any index you access in A and B in this example, they would be exactly the same because, yeah, they both refer to the exact same list. Yep.
Thank you.
All right. Great. So this next example is going to involve a function. And before I have you work on this, I want to explain one piece of syntax that is new. But it's sort of a shortcut that you'll find handy and will be useful in future programs. So we see this line here, I is, and we're going to come to learn this means I is incremented by 1, but this is a new piece of syntax. What does it mean? Where is it coming from? So in the past, we've seen a lot of statements that look something like x is assigned x plus 1, or I is assigned I minus 1, or y is assigned y times 10. Or maybe if we were dealing with bank accounts, we could imagine something like account is assigned account minus $100 or something, right? These types of statements are so common, there's a special shortcut or shorthand operator called relative reassignment operators. Right? So relative reassignment are operators that do the exact same thing. All right? So this first example we could have implemented as, or written as x plus equals 1. This second example we could have written as I minus equals 1. The third as y multiply equals 10. And you're probably wondering, like, why do we need an extra piece of syntax, an operator, when we're saving, it's only like sort of reducing these lines by 2 characters. Well, one of the things we'll see is as our variable names get longer, or as we're reassigning values that are in our lists or in objects, we'll learn later in the semester, what goes on the left-hand side and the right-hand side can get pretty long, and this actually can save quite a bit of typing and avoid accidental errors. So this one would have been, account minus equal 100. Right? So all the arithmetic operators, as well as some of the Boolean operators, can be done using relative reassignment. And that's what you're seeing here. So it's very frequent when you're writing while loops in the future to use relative reassignment rather than I is assigned I plus 1. And as you become more comfortable in Python, typically experienced Python programmers will use this style rather than the more explicit one that we've used in the past. All right, so that's the only piece of new information that we're seeing on this slide. I'm going to leave those notes up there, but I'm going to turn it over to you all to try working through the second challenge question and diagramming it. And remember what I said, the principle of how references are passed rather than copies when we're dealing with lists is going to apply to setting up this parameter in the dupe function call. All right, so go ahead and take a stab at that. And feel free to work with your neighbors. 2 more minutes on this one, 2 more minutes. Thirty more seconds. All right, let's walk through this example together. And again, we're seeing some concepts for the first time, but the same principle that we saw before, where you copy a reference to a list rather than copy the entire list, is going to be at play here. And so when we get, I went ahead and set up the dupe function definition between the stack and the heap, and now I'm ready to process or evaluate line 13. And once again, we're seeing that we have a list literal on the right-hand side of an assignment statement. So whenever you see a list literal, we need to set up a new list in the heap. To know what type that is, you can either look at its initial values, and here we see they're integers, and say, okay, this is going to be a list of integers. Or we can see how it's being used, and we see that it's being assigned to a list of integers. So I'm going to set up a table where the header of this table is the type of the values that this list will store. And we should add our first 2 values, right? So our values were 10 and 20. So 10 and 20 are going to be at the indices 0 and 1, respectively. Right? So once again, our left column is the index, and the right column are the values associated with that index in this list. And what are we doing with this list? Well, we're assigning it, or a reference to it, to a variable named nums in globals. Right? So nums in globals is going to refer to that list that was constructed using list literal syntax. So again, the square brackets, when you see it used as a value, it means we're working with a list literal. When you see it used with a type, it means we're saying a list of integers. And then when we see it used, with the indexing or subscription notation, we're saying look up some value in this table. So we'll get there. All right. So then the next important line is line 14, and here's where we need to be careful, because this is where a new dynamic is coming into play. We see a function call. We ask ourselves, have we seen something named dupe defined? Yes, it's a function defined on lines 4 through 10. Great. We ask, do the parameters of this function definition match up with the arguments that we're trying to call this function with? So nums is the argument, and there's one argument, nums. Its type is a list of integers, right? We know the variable name nums has a type of list of integers, and that corresponds with the single parameter that dupe defines, whose type is also a list of integers. So there's a correspondence between the arguments, the parameters, that checks out. And then we need to look at, well, are we using this in a way that's correct? Well, here we're not doing anything with the return of dupe, and that's okay because, and that's actually great because this function doesn't return anything. This is a procedure that returns none, right? Just like our main functions will tend to be. And so we're ready to set up this frame. So we add the name of our function to the frame. So dupe is the name of the function call. The return address is the line that this call occurred on. That's line 14. And then we need to set up our parameters. So our parameter is x's, and here's where we need to be careful. We are saying take whatever nums is. So, okay, what is nums? Nums is this reference, right? And I'm going to change colors again just to emphasize this. Nums is this reference to this list on the heap. So we need x's. When we say, okay, assign to x's, whatever nums is, x's is also going to be a reference to this value on the heap, all right? And we're ready to jump into this function definition, or this function call, all right? So we go up to the top of this function definition, and we see that we've got docstring. We don't do anything with that. And next, we are going to set up a variable named startlen. And it's assigned the length of x's. So len is a special function we've seen in Python in the past. And it tells us how many items there are in a list or how many characters there are in a string. There are 2 items in this list, right? 10 and 20 are the values. So the length of x's is going to be 2, and we're assigning that to our startlen, right? So remember, the len function means how many items are in a list, right? We then reach an I initialization. Our current frame is still the dupe frame. We haven't returned from it, so I is going to be initialized to 0. And we reach a while loop. So we test is I, which is 0, less than startlen, which is 2. That's true. So we go into the loop, and here's where we see an append method being called. So x's in our current frame, dot, we follow the arrow, so we're talking about this list table, append, and then x's of index I. So x's, and then when we look up the index I is currently 0. That's going to be the value 10 here, right? So what we're saying is x's.append, and then 10 is what that expression evaluated to. So ultimately, we're going to add another item to this list, and the value will be 10 for that item, all right? We then reach line 10. We have the addition reassignment, or relative reassignment operator with addition. So I is incremented by 1. So I goes from being 0 to 1. And we go back up to the top of our loop. We test again. Is 1 less than 2? That's still true. So we are trying to append now. X is at index I. Well, I is 1, so if we look at x's and we look in this table at index 1, we see that that has a value of 20. So we're saying x's append 20. X's dot, follow the arrow to this table, and we're appending to this table. It's going to have an index of 3 and a value of 20. Right? We've completed line 9. On line 10, we're incrementing I by 1, so it's now 2. We go back to the top of our loop. Is 2 less than startlen? Startlen is 2. 2 less than 2 is false, right? So we're done with this loop, and we reach the end of this function definition. There's no return statement, right? And what we have to remember is that's okay. For functions that return none, there's this implicit, meaning you don't have to write it, but it's always there, return none statement. That means our return value of this function call is going to be none. And we return back to line 14. So we've completed line 14. And now we print nums. So our output, when you print a list in Python, is the list literal representation of the items in your list. Right? So what do I mean by that? Well, the output's going to be square brackets because we're printing a list. And then we look and we see, okay, the first value was 10. The second value is 20, so 10 comma 20. Third value is 10. And fourth value is 20, right? And so this would be the output of our program. The important lesson that we're really focused on here are these purple arrows, which are giving an illustration that when you call a function and you pass an argument that's a list, you're not passing a copy that's a list, you're passing a reference to that list. So if that function changes something about regarding that reference, starts appending to it or changing the values inside of that list, when that function completes, even if it didn't return anything, like we're seeing here, that list will have changed because both, in this example, both nums and x's, 2 separate frames on the stack can refer to the exact same list in memory on the heap. And this isn't something you had to worry about or keep track of with integers and floats and bools because we did copy those values frame to frame. And this is one of the fundamental reasons why we spend so much time on diagrams, because if we didn't have a visual representation of this, this would be quite a confusing phenomenon to make sense of in your head. Questions on this example? Got a question over here, Clayton.
Can you explain why the return value is none again?
Yeah, so the question is, can I explain why the return value is none? So the return type of this function, dupe, is none. And this is sort of a special case of a function. And we give this type of function a special name, procedure. And this was something that you read a little bit about in the last project, and we've talked a little about in the context of main procedures or main functions. And so any function that returns none, you could have written return none down here, and that would be okay, but typically you're never going to do that because it automatically is always the case that at the end of a function that returns none, there's this implicit, meaning invisible but actually there, return statement that does that on your behalf, and the none value is what gets returned. Thanks. Other questions? All right. So we've seen now when we assign one variable to another that's a list, we copy a reference. We've seen that when we call a function with an argument that's a list, we copy the reference to the parameter. Here we're going to see one last sort of modification, or one other place we need to be very careful, which is notice the return type of this function is a list of integers, right? So this is going to be a function that produces a list of integers, or returns a list of integers, and it's given just 2 integers as parameters, right? When you return something that is a reference type, such as a list, you're going to be returning a reference to some value on the heap, right? So just like we copied arrows before between variables, your RV in the odds frame when you set this up is going to be an arrow to some list on the heap as well. And with that sort of preface, I'm going to go ahead and turn it over to you. And just be careful and remind each other of what's going on in this kind of clever, cute arithmetic statement. All right, so let's spend another 10 minutes on this one. 2 more minutes on this one, 2 more minutes. Thirty more seconds on this one, 30 more seconds. Madison, can you grab this? Twenty more seconds. All right, let's talk through this one together. If you didn't quite get there, that's okay. This one has a loop that's a little bit longer and some arithmetic. But I've gone ahead and fast forwarded through things that we should be pretty comfortable with up to this point. I set up my globals frame. I made a function called odds because that function call occurred right here. And I went ahead, and this is a valid function call. The only thing I want to mention about this function call that we didn't see in the previous example that is worth mentioning is when we look at this function call and we ask, is this a valid function call where it's being used, we have to look at its return type. And we see that this is a function that's going to return to us a list of integers. And we are assigning that to a variable, which is going to refer to a list of integers. So that checks out. That's OK. I went ahead and set up my parameters, min and max, 3 and 6 respectively. And I'm ready to jump in. And on line 6, what we're seeing here is we're constructing a new list. Right? And this list constructor sets up an empty list. The other way of setting up an empty list is just with list literal syntax, where you just see some empty square brackets with nothing inside of them. And that would have been OK to use in place of this. They both achieve the same thing. Right? But I wanted to give you an example with this list constructor. And so how do we represent an empty list on the heap? Well, we need to look at what type of list this is going to be. It's going to be a list of integers. So I just set up the header list of integers. And it's going to have no rows below the header, right? We don't have any values in this yet. It's just an empty list. And we need to bind that object to the name x's using a reference. So x's in odds is going to refer to this list, which is currently empty. Right? So x's now has a reference to that list we just constructed. And we've completed line 6. On line 7, we have a little bit of arithmetic to do. So this is just a little bit of clever arithmetic where we're dividing by 2 using integer division. So remember, this trick here is min is 3, right? And if we imagine 3 divided by 2, that's going to be 1.5. But integer division, you get rid of whatever that decimal is, right? So it's just the value 1. And then we turn around and multiply it by 2. So this expression becomes 1 multiplied by 2 plus 1. So 1 multiplied by 2 is 2, plus 1 is 3. All right? And so now we have 3 being initialized to I. And if we have time, I'll come back and talk a little bit more about that expression. But basically, we're trying to use this expression to get the first odd number that is min or 1 greater than min if we had called this with a min that was even. In this case, we called this with a min that was odd. And so we got back the same number that we started with. All right, but I is 3. Next, we reach this while loop, and we ask, is I, which is 3, less than max, which is 6? 3 less than 6 is true. So we go into the loop's body, and we append I, which is 3, to x's. Right? So x's dot append means this empty list is now going to have a first item in it, which has at index 0 a value of 3. And then we reach the relative reassignment operator, where we're using addition reassignment to say I is plus equal 2. So 3 plus 2 is 5, so I becomes 5. All right, so we then reach the bottom of that while loop body. We go back up and we test again. Is 5 less than max? Less than or equal to max? Well, max is 6, so that's still true. We go into the loop one more time. We append I. I is currently 5, so we're appending the value 5 to x's. Right? And then we reach the next statement, which is increment I by 2. So I is now going to be 7. And we reach the end of this while loop body. So we jump back to the top. 7 less than or equal to 6. That's now false. And so we're done with this loop body. Right? So in that loop, we appended 2 items to our list. And what we got was a list with a length of 2, and I's final value is 7, which made this loop terminate. Then we reach line 11, and on line 11 is where we reach a return statement, and here's kind of the whole point of this diagram, so I'm going to change colors. What happens when we return a list? Right? So what I want you to know is that when we return a list, what we're going to do is we're going to return, well, we ask, what is x's? Right? We've asked this question before when we've had lists, like what is x's? X's is this reference to this list, right? So the return value, and this is going to start to feel like it's a little bit crazy on the diagram, but the return value is also going to be a reference to that list, right? Before I move on to what we do with this return value, actually, yes, before we move on, what I want you to avoid and know that you can't do, I'm going to draw this in red so that it makes it very obvious that I don't want you to reproduce this. Don't do something like this. Don't draw an arrow to somewhere else in your stack, all right? Also, don't say return value is x's, all right? We want to be very careful and explicit that our return value, when we're returning something that's a reference, is a reference to the place on the heap that we intended to return. You are never going to draw an arrow from one place on your stack to somewhere else on the stack, right? The pointer of the arrow is always going to be somewhere on the heap when you're working in Python and most other high-level programming languages, right? So you're never going to have an arrow that goes somewhere on your stack, on the heap. All right, so what do we do with this return value? Well, we return it back to line 14. What happened on line 14? Well, that was way down here. And let me change back to blue real quick. And on line 14, odds results in a reference to this list with elements 3, 5 in it. So we're assigning that to y's. So now y's is also, and I'm going to go back to purple here, also going to be a reference to this list, right? And now we've completed the function call for odds, and we've completed line 14. So when we go and we print y's, we would see the output is the list literal 3, 5. And why is that? Well, we look at what is y's. Y's is this reference to this list whose items are 3 and 5, right? And you can kind of get the sense if we had called this with, say 3, 9 as our arguments, we would have had a list back that was 3, 5, 7, 9. And so this function is generating a list with all the odd numbers between its 2 arguments that it was given, right? Questions on this example? Question up here. And
So, when normally like we would read odds and we would add it to globals, and then we would read ys and add it as a variable. So like when we read that and then we see like lists of integers, don't we like add it directly to heap, and from there we were like can.
so if I'm understanding the question, and correct me if this isn't it, the question I believe is we start by adding this definition for odds to globals and establishing it on the heap. And on line 14, we see that y's is going to be a list of integers. So one of the things that you could do is you could set up a space for y's and just not assign any reference to it. But what I want to encourage you not to do is try and set up something in the heap that is going to be a list of any type until you see something that is either a constructor or a list literal of like 1, 2, 3, right? So the only time you actually get an object that's a list in the heap to show up in memory is one of these two scenarios, right? That list does not exist until this function call occurs here, or if we add a literal. So there are steps between, like we have to set up this function frame before we get into that. And you might be wondering, well, why is that? I could imagine, and we could, in a future class, I could come up with a demo of this function could actually produce multiple lists in memory and return only one of them back to you. And you wouldn't know which one you were working with and you wanted to associate with y's until that function actually returned. But that's a little bit beyond our scope here. So just be careful. It's totally fine to leave, like if you see a variable declaration and you want to leave yourself a little bit of space here, to go ahead and set that up before the function call. But don't assign it any value until whatever is on the right-hand side has completed and you know what actually is returned from that function. Good question. Other questions? All right. So what we're going to do next is a little bit different. We're going to be writing some code in VS Code. So if you want to put your notebooks away, we can go do an interactive coding example together. And while you're getting your laptops ready, I'm just going to briefly explain what's on this slide. We're going to be implementing a function together that has some specifications. And this will be very similar to what you find yourself doing in the next exercise, where we tell you a little bit about what kinds of parameters we expect your function to have, what the name should be, and what we expect it to return. And so this is going to be a function that we give it a list and some value, and we're trying to determine, does that value exist in that list, or does that list contain the value that we're looking for? And we'll name these two values the needle and the haystack, right? Which is the idiom of sometimes you're trying to find a needle in a haystack. You can imagine our list has 100. It's like a dictionary of every list in English, or sorry, every word in English, and it might have 100,000, 200,000 words in it. And we're trying to test, is this word spelled correctly? So we need to go look it up in a dictionary. That you can imagine one example like that. We're not going to have a list nearly that long. And the point of this function is to return true if the list does contain the value we're looking for and false otherwise, right? So in VS Code, what I'm going to do is set up in lessons a new file, and the file will be named contains.py, right? So I named my file contains.py, and let me make this a little bit larger on the screen. All right, let's go ahead and set up a docstring example of a function that processes a list. Okay. One of the things that I'm going to encourage you to do before you start writing code, before you start trying to just dive right into it, is try and jot down some notes using comments of what it is that you're trying to do. So what we're trying to do is define a function named contains. And what can we give this function? Well, the previous slide said we can give two arguments, a needle value we're searching for in a list, in a haystack list. All right. And the terms needle and haystack are not, we could have chosen any names for those. I just like using these two words because it makes it obvious which value you're trying to use in which way. So we're looking for the needle in the haystack. All right. And what should this function do? It should return true if needle is found in haystack, false otherwise. Right? Now, that's a sentence that has a lot of implications in it. Based on what we know so far, there's not a way of just directly returning true if it's found in the haystack and false otherwise. we're going to need to write a loop here to move, and so we need to think through what is the algorithm we're going to use. And we're going to use an algorithm that just starts with the first index of the list, index 0, moves through each index in the list, and asks, hey, are you the needle? No, okay. Next index, is your item the needle? No, okay. Next index, is your item the needle? Oh, it is? Okay, yes, we can return true from this, and we're done. And otherwise, if we search the entire list and we don't find the needle anywhere in it, we can return false because it wasn't found. So if we wanted to, we could be a little bit more specific, such as saying loop through each index in list, test if item stored at index is equal to needle, return true if so, and otherwise return false after testing each item, right? And so you can see we're starting to get a little bit more specific, and we're not quite there yet. This isn't code. These are still just English comments. The computer can't do anything with this, but we're at least coming up with a strategy here, right? So once you have an overarching strategy, it kind of helps to start scaffolding in some code, all right? So we need to define a function named contains. Okay, we know to define a function. We can use the def keyword and contains. And we know that we need to be able to give it 2 arguments. And let's say we're searching for strings. So let's say the needle parameter is going to be a type string. And the haystack will be of type list of string, right? And we know with the function definition, we also need some return type established. So we have to think about, well, what is the return type going to be here? Well, we kind of see in our notes, okay, we need to return true if the needle is found in the haystack, false otherwise. So we know that this is going to be a function that ultimately is going to return a Boolean, right? And one of the ways that you can get started with a function like this to make it a valid function that we could actually test and see if it's working, we're not going to do that quite yet, but we could just say, okay, return false as the very last line of this function. And we knew that we kind of needed to do that anyway, right? We still have more work to do in actually searching through this and looping through each index in this list. But we know that if we don't find anything, we want to return false. And this actually makes this a valid function definition. It doesn't make it a valid function based on what it's supposed to do, right? This isn't going to work. It's always going to return false. But we could call this function, and this is a complete function definition. Okay, so our next note is we loop through each index in the list. We have sort of built up a little strategy for doing that, right? We set up an I counter variable. You can name it whatever you want. You can name it counter. That's initially 0, right? We start at the first index of our list. And we need to loop through each item in our list. So I might write a while loop. So while I is less than the length of what are we searching through? The haystack, right? So haystack is our list of strings. And then before I worry about this test if the item stored at the index is equal to the needle, we want to be sure we're not, it's good practice to just be sure your loop isn't going to be infinite. So in this loop body, I've indented, and in this loop body, I'm going to say I plus equals 1, right? And so we know, having spent some time with while loops, that this is a pattern for moving through each index in a list, or each index in some range of numbers. Start from 0, add 1 each time we loop, and we test until we get to the end of that thing that we're looping through, okay? So we're almost done. We just need to kind of make this last little bit of logic true. We want to test if the item stored at the index is equal to the needle, all right? So how do we know what the item is stored at the index and whether it's equal to needle? Well, we could do something like if haystack index I, right? And that's going to look up what is the value stored at index I of our haystack, what we're searching through. If that's equal to, what are we testing if it's equal to? Well, we're testing if that's the needle, right? How we found the needle value in our list of values. And if we have, well, we've got this note here. We want to return true, right? And I'm going to actually indent this first comment here. Otherwise, I would have a syntax error because of Python. And I'm also going to just try and get rid of some of these silly syntactical. Some of the red underlines that you might see if you hover over it, so let me just do this real quick to show you, is it says expected and indented block. If you see that, if you hover over an error and you see that, and you indent and save, it should hopefully go away. All right? And so notice this sort of strategy that we took on here. We started with trying to jot down what do we think we want the program to do. At some points, we realized, oh, what I'm explaining here is a little bit more high level than I can write code to actually go do for me, so let me try and break that down into some further steps and further subdivide my problem. And then once it feels like you can actually express some English with some code, for example, test if item stored at index is equal to needle, in code, if haystack index I is equal to needle, then, and we've translated that one-to-one, and at some point you can actually start removing your comments, right? Because we don't really need these if you don't want them. And so a valid solution would look, something where we don't need all of the comments that we had. One other thing I should mention is we should add a doc string here, and our doc string can be what we just described. So return true if needle is found in haystack, false otherwise. All right? And after I remove those comments that I started with and have that doc string, we've got a cute little function here that we can go and play with. Right? And this function will test whether the needle is contained in this haystack. And what I want to show you are two strategies for actually testing this function that you might want to make use of. Right? The first strategy, I'm going to open a terminal. So if you go to View and then Terminal, and I'm going to start up in my terminal a Python REPL, so Python. Right? And what I can do now is import this function into my REPL so that we can test it. Right? And the way that you'll do that is you'll use the from keyword, so from, and then lessons.contains, import, and then the name of the function. Right? And I want to pause here for just a moment. I'm actually going to open up a pen here, Epic Pen, so that I can annotate my screen for just a second. All right, so as I'm running my Python program interactively, so I started the Python REPL. You know that you're in the REPL when you have the three, the chevrons, the three greater than symbols. And from, lessons is the directory this was stored in, right? So if I was working on an exercise, this would be exercises. And then dot, contains is the name of the Python file. And it just so happens that in this Python file, we also defined a function named contains. So we're importing this contains function, right? If we had a function named main and we wanted to import it, we could say import main. But here our function was named contains. And so what I can do now is actually evaluate this line. Oh, shoot. On my laptop, I've got an old version of Python. Hold on, Python 3. So I've got in VS Code Python 3.9, but for some reason my REPL is using Python 3.8, and we're actually making use of something that is. All right, you're going to have to take my word for this, and when you try it in yours, it will actually work. So from lessons.contains, import contains. And for right now, ignore what I'm about to do. Don't change your program. We're using some modern Python, right? So I'm on my laptop, I've got an old version. All right. There we go. All right, so now I'm going to put that back in. And now what we're able to do is actually set up a list variable. So let's say we have a list of names. And I'm not going to type my variable here. You could say list of stir. But this is actually a modern Python feature that came in 3.9, not 3.8. You don't need to know that, but this is why I'm not doing it. So names is assigned, in my case, I could say Chris and Khaki. All right, and now I have a list of names that's at index 0 is Chris, and names at index 1 is Khaki. All right? Let me see if I can get this all to show. Great. So the next thing we want to do is use our contains function. And can we try calling our function? So contains, after I've imported it, I can give the needle is going to be, let's say, John. And we're testing as John in the names list, or the names haystack, and that's false. But if I wanted to test, what about Chris? That's true. And I could also test, well, what about Khaki? And that's true. What about Kevin? That's false, right? And so if you define a function in a Python file, you can interact with that function in your REPL by starting up a REPL and then using the from syntax, which you've seen before, like when we used a random function. And let me scroll up to that. From, and then the directory, dot, the file name, import, and then the function you want to make use of. And then you can start calling that function in your REPL, all right? Now, you want to be very careful because if you make changes to your program, they're not automatically reloaded, right? So if you made changes to your algorithm, you need to press the trash can on your REPL and start over to test those changes interactively. So be careful of that. The changes that you make when you're working on a file are not going to be reloaded automatically in the REPL. The last way that I want to show you really quickly how you can test your functions is to set up a main function. We've seen this before. So I'm going to set up a main function. It will return none. And I could set up a very similar example where names is a list of stir. And it's say Chris Khaki, and you can add whatever names you want. And from here, I could try printing the result of calling contains, with, say, Chris and my list of names. And you could test your function in this way, but remember, in order to call your main function, we need to use the idiom in Python that's very common. I'm going to make my screen just a little bit, or my text just a little bit smaller here, which is if, and we talked about this in a lecture, in 2 lectures ago, name is equal to main, both of those surrounded in double underscores, call the main function. And I'm just going to make a note here, Python idiom for starting the main function, right? And so if you were to actually go and run this program, what you would find is it would call the main function, and the main function would print true because Chris is contained in names. Right, so you've got 2 options in this next exercise for testing your functions out. You can set up a main function like you're seeing here, and make some function calls to it, and then just rerun your program, look at the outputs and test it in that way. Or you can start up a REPL, and just like we saw before, you can import your functions into that REPL and test them interactively. But remember, when you do that, you have to restart it if you change your file or you change your function definition in order to make different tests. In an upcoming lecture, we'll look at even a more advanced but also more handy way of rerunning common tests over and over again. This will be a little bit labor intensive. I would encourage, once you get comfortable with a function and feel pretty good about it, to set up tests for it in the main function just to convince yourself it works. And then the auto grader will ultimately be just looking at the specific implementations of your functions, all right? Questions on this code listing? Yep, question back here. And Clayton, I might have you run the mic back so that we can hear the question on the live stream.
Are we turning in a screenshot or a zip file?
For this one on Gradescope, just take a screenshot of your code for this. Yep, question here.
Can you just quickly re-explain why it was true? It returned true.
Sure. So let me use my pen here really quickly. So the gist is, in this example, we have a list of names, right? That's going to be a list of stir. And at next 0, it's the string Chris. And at next 1, it's the string Khaki. Oh, and there is actually one really important, this brings up a great question that I need to explain here. which is, and let's imagine actually that Chris is in this list twice, right? And I could update my code to reflect that just very quickly. All right, so let me add myself here one more time. And this is totally fine, right? Lists can have duplicate values in them. So what happens when we search for Chris, right? Well, needle is going to be the string Chris, and haystack is going to be a reference to this list, right? And so what we do is we set up a variable I at 0, so we're starting with this element here, and we're asking, is haystack at index I, which is the value Chris, is that equal to Chris? And if so, we return true. Now, as soon as you hit that return statement, what's very important to hear, and there's a question about it on Gradescope, is that this function is going to immediately return true. True will not be returned twice, even though Chris is found later in the list. Like, this loop won't ever loop again. We're going to return true immediately, such that the function itself will result in a single true value. So even if there's a return inside of a loop, once that return is evaluated, that loop and that function are complete, and we return true. Now, on the other hand, if I had searched for, Mike here, we would have tested, is this Mike, is this Mike, is this Mike, and we would have gotten to the end of that list. We wouldn't have found Mike anywhere in the list, and we would have returned false. Good question. All right, so this is a code listing. This is what the next exercise will feel like in writing some algorithms, processing loops and lists. Great work today, and we will see you next week.
So what does this? I mean, in the description here it says that only
Thank you.
and then and so it will not
We only make use of the built-in link function and the list of simply reference. So
Yeah, no, it's,
there's
we're still open, it's just,
yeah, so it's kind of a slice notation. I believe that is different there in the next thing. Here.
with
There's like
the
a,
subscription operator.
yeah, so the thing I would say, I guess in this case they do just want you to use a pin
Hey.
instead of using the specific index.
So like when we're
Confusing
working with
that really
this,
go
we
over
don't
fast
have
into
to like
there.
go and say global and
Because
then very the way we do this with like the
the
clauses,
first
right?
it's not
It's like it's something that you can reference at all time. If we reference the same thing.
Yeah. And so the key difference is this global, what you're saying is I'm not
More
declaring a
complicated.
variable in my local
I'm not sure
frame.
if that's the goal.
Yeah,
I'm
so
wanting to refer
that line
to
there, right? There's a
variable
function
that
in
declares
Python
a
called
global string.
slice.
Um,
So I think that's
and
the
so
bigger concern.
normally when you
I think
declare a
you are
variable
allowed to
in a
use
function
something.
body,
It could be.
you'd add that variable's
Well,
value.
it says in conjunction
function's,
with the subscription operator, but I think as long as you don't
frame.
use the slice function, it's
The
fine.
global says, hey, don't do that.
So
Look
this should
to
be fine.
globals.
I'm pretty sure.
Go back directly and
I would be
read.
very
But with
surprised
this,
if they
you're
didn't
just
want you to
not
do that, given that you went over
So it turns out you
today.
can have lists,
Yeah.
and we could have had a list declared
No problem.
globally, and we could have used a global list from within a function later on. So we could combine those two ideas. They are separate from one another. But with lists, what's different is, yeah, whenever you make a copy of a list, you're actually copying a reference to that list, so that now you've got two things referring to it, or three things referring to it. Yeah.
Thank you.
Yep.
Really really quick question. I want to make sure I got this right. When you're in a while loop and return,
Yeah.
it's only return once.
Only return once. That's right.
So it just breaks it?
Yeah, it just breaks up right out of the loop. The function's done. You return back to where you came from.
That's good to know. Thank you.